Okay, so we're going to pick up exactly where we left off. All right, so what we want to do is we want to figure out, do we think that all perpendicular lines are related in the way that we observe, right? Potentially opposite reciprocals. So what I want you to do is I want you to investigate this by drawing 3 different lines with the slope triangles on your graph paper. It doesn't have to be slope triangles, but we just want to draw the lines. Make sure that you know which one is the 1, 1/3, and the negative 3/4. Remember, for the negative, keep the negative, right, in one or the one of the other. Oops, I don't know why I just flipped my fraction. Um, Keep the negative in either the numerator or into the denominator. Personally, I always think that this is a little bit easier. Okay, so then you're going to rotate it 90 degrees. Again, it could be counterclockwise or clockwise. Draw your new line, determine your slope of your new line. You might want to draw these on three separate graphs. Again, what we want to ask yourself is how does the slope of each rotated line compare to the slope of its original line? So for 1, what's our new 1? 1/3 and 3/4. Right? And then again, we want to come up with a generalized relationship of perpendicular lines. So go ahead, take a moment, pause the video, and answer these 3 questions. When you're done, come back and kind of see how your answer matches up with what I have. Okay, so if we are back, we're going to go ahead, we're going to check out our lines. So our first one is with just a slope of 1. So here's my slope of 1. What we can see is I started at the origin, and then I went up 1 over 1, up 1 over 1. Okay, so that's what we can see on this one. So if I rotate it clockwise or counterclockwise, what we should have gotten was something that looked like this, and my slope is actually negative. So whereas if I come over here so I can actually show you, so notice that a positive 1, and then we're actually going to have a negative 1 as my slope. So that's what one of the pictures. For the second graph, turn this one off. For the second one, we had a 1/3. So again, I made my life very easy and kept it at the origin. So I go up 1 over 3, up 1 over 3. And if I did my rotation again on my patty paper and moved this over, you will see a negative slope. And we're actually going to see this as -3. So your graph is going to kind of look like this. It almost looks a little bit steeper. So again, I'm going to go down 3 over 1 instead of up 1 over 3. So these are reciprocals of each other. Notice again, one's positive, one's negative. And the last one was 4/3. Right? So if you have 4/3, again, you're going to go up 4 over 3. And then if I flip this or rotate it around again, one of the points, I picked it as 0, 0. Life is really easy with that one. I believe, sorry, I just gave you the answer. This one was supposed to be -3/4. Sorry. Down 3 and then over 4. And then the new graph was actually 4/3. So I gave you the answer before the original one. But again, these you're going to see create a 90-degree angle. Okay. So now that we've kind of addressed that information, let's come back to here. So using our tracing paper, what did we notice? So our first one was 1, but then it went with a -1. So 1/3 went with -3 over 1. And then finally the -3/4 went with a positive 4/3. So that's what we should have gotten out for part A. For part B, how does the slope of each rotated line compare to the slope of its original line, right? So basically what we should have said is slope is made up of, change in y and then change in x. So basically change in y, change in x, switch, all right? And then positive slopes become negative and vice versa. Meaning negative slopes become positive. So that's what we should have probably said for something in part B. Part C, use the patterns from the work you've done to describe the general relationship of the slopes of the particular lines. So again, what we're here is we're saying the slopes are opposite reciprocals of each other. And it's important to know this so that way we don't have to use tracing paper in order to figure this out. Okay? So I want you guys to copy this down. So slopes of perpendicular lines. So again, here's our original. So that becomes A and then B, 90 degrees. Here's our perpendicular. So two lines are perpendicular whenever one line can be rotated 90 degrees onto the other. However, your rotation does not only move the points on the line, it also moves all the points and shapes on the graph. The axes do not move. Therefore, the relationship of the slopes of the perpendicular lines can be demonstrated as true by rotating a non-special line along with its slope. So again, these are our slopes that we are dealing with. Okay. So what we want to do is we want to figure out how can we prove this. This has worked so far with this -1 and 1, they're opposite reciprocals. 1/3 and -3/1, -3/4 and 4/3. So what we want to do is we want to prove this, right? So, however, to prove something mathematically, you must be able to explain why it is true in all cases, not just particular examples. This is a particular example, right? So to prove this, Sabrina drew the picture above. So she drew this picture right here, okay? And so what we want to do is we want to use her drawing to explain why the slope of the perpendicular line must always be -b over a if neither a nor b is equal to 0. Because again, if it's 0 over a, that just equals 0. And if it's b over 0, remember that this is undefined. And then what happens if the original line has a slope of 0? We want to explain kind of what happens. So go ahead and pause the video and think about how we could potentially use this drawing. Notice that there's no letters, there's no numbers, there's only letters, no numbers to kind of help us prove it. So go ahead, pause the video if you need to rewind it to kind of look at this picture so you can copy it down. That would be great. Okay, so hopefully you're coming back. Maybe you're having difficulty with that. This is okay. We're going to be talking more about how we prove things. This is not really a formal proof yet. That's more for second semester. So what we basically can say is why this is always -b over a is we've learned that your a and your b kind of switch. So that means that this is your vertical line. This would become your horizontal line. This is horizontal. This becomes your vertical. So again, this would be your B, but notice that we're going down. So this would be your -b over A. So again, it rotates. So again, our change in X and our change in Y, right? Change in X and change in Y, they are going to flip. And notice that as one is positive numbers, one has to be negative numbers. That's essentially what I was looking for on this one. Again, it's a little challenging, I understand. Okay, so hopefully the second one will make a little bit more sense. So what happens if the original line has a slope of 0? What happens if you rotate it? So again, if I just quickly drew a line of 0, so bam, so this means that your slope is 0 over some number, right? Doesn't matter. Well, remember, something's going to flip, right? That means that your new slope, your perpendicular, and just FYI, the symbol for perpendicular is an upside down T, right? So that's your symbol for a perpendicular line. So if I flip this, that means some number is going to be on top and a 0 is going to be on the bottom. So what is that? It's an undefined line. What does an undefined line look? It looks like this, right? So your black goes with that kind of line. This would be an x is equal to equation, where this is a y is equal to. So this would be x is equal to some number, whereas this is a y is equal to, not 0. I mean, it could be 0, but we don't actually know. It's just equal to a number. So again, this is great. Perpendicular and perpendicular lines are your pure x and y axes, right? Your y-axis and x-axis, they do meet up at a 90-degree angle, which means they're perpendicular. So x-axis and y-axis are examples of perpendicular lines, right? So you've been staring at perpendicular lines all this time and you had no idea. All right, so what I want you to do is I want you to go ahead and I want you to pause the video and try graphing and coming up with equations with these problems.